Your record sheet should have your first and last name, then the date, 10/31/07. Today's Halloween. Focus is the lamp. The problem is, why does the lamp light with B but not with A? And then we're gonna try to gather enough data to form a conclusion and answer it to that problem. The focus today involves this piece of equipment, and I'm gonna name the parts. This is a piece of electrical equipment, and if I set it up right, the lamp will light. Okay, now, the lamp will only light if the electricity is going in a circle. Electricity has to go in a circle to work. All right, so if I break the circle anywhere, the lamp goes out. All right? You're gonna have to draw this diagram up here on your papers, on the back. This goes on the back. And I want you to write the word circuit. Comes from the word circle. It's an electrical term. And some circuits are complete, and some circuits are incomplete. A circuit is complete if the lamp lights. If the lamp isn't lighting, it's incomplete. If the electricity can go in a full circle, it's a complete circuit. Okay, and then the power's on. All right. Now, it's a complete circuit. The electricity comes out of this battery. This battery has two terminals on it, a plus and a minus, or a positive and a negative, as all batteries do. Next time you look at a flashlight battery, notice that one end is labeled plus and one end is labeled minus. Okay? Plus is positive, minus is negative. The electricity comes out of the battery through the minus term, negative term. But it has to go back in through the positive terminal in order to form the complete circle. Okay, the electricity is coming out of here to this wire down to this coil. And then because I'm touching the coils, it can go from that coil to this other coil, up to this wire, to the lamp holder. And then it goes through the lamp. There's a little tiny wire filament in the lamp that the electricity is passing through. And from there, it goes through this other wire back to the positive terminal of the battery. The reason that an electric lamp works is that I'm going to draw a big version of a light bulb here. Thomas Edison invented the light bulb. All right. In the light bulb, there is a little wire called a filament, and if you look at a clear light bulb sometime, you'll see this. It has two ends here, and one end is connected to the incoming electricity, and the other end is connected to the outgoing electricity. Edison discovered that if he put an electrical current through a tungsten filament, it would glow. And that's how the electric light bulb was invented. I have been told that Edison tried over 400 different substances before he tried tungsten. None of them glowed. He wasn't sure what he was looking for. But when he tried a tungsten filament, he knew he had found what he was looking for, and that was how he invented the light bulb. Tungsten glows when you pass electric current through it. Okay, so now it's an incomplete circuit. The lamp is not on. Now it's a complete circuit. The lamp is on, and there's electricity flowing through the filament. If you've ever shaken a burned out light bulb, you might have heard something rattling around inside. That's probably the broken filament. When a light bulb burns out, it's usually because the filament has broken, and then you can hear it rattling around inside. Okay, now, obviously you can make a complete circuit by touching the coils, but it's also possible to make a complete circuit by putting something between the coils that'll conduct electricity. So I'm going to test several objects. First, I'm going to test my car key to see if it's a conductor. Okay, it's a conductor. Who's got a coin? Anybody got a penny, nickel, or dime, or quarter?
Oh, there's a penny.
Oh, there's a penny. Okay, bring the penny up. You don't have to reach over. Okay. All right, let's try a penny. Is it a conductor?
Yeah.
Yes. Okay, who has a pair of scissors? Anybody right here? Okay, Emily's got a pair of scissors. Let's try it. Let's try the metal blades of the scissors. Are they a conductor?
Yep.
Are the plastic handles a conductor?
No.
Who has a wood ruler with a metal edge? Anybody have a wood ruler with a metal edge? They don't make those.
Sunglasses.
Good, good. Okay, let's try the wood ruler. Is it a conductor? No.
It just flashed.
Let's try the metal edge. Oh,
No.
yeah,
Yep.
metal edge is. Okay, now he has a metal ruler with a cork backing. Let's see if the metal, oh, the metal's a good conductor. Let's see if the cork is a conductor.
No. Nope.
Okay, let's try our water bottle, Stevie.
Yes.
Is the water bottle a conductor? Yes. Who has a plastic, let's try Jake's plastic water bottle.
Yes. No.
Is it a conductor?
No.
Okay. Raise your hand if you can tell me an adjective that describes all of the things that were conductors. One word, Wyatt.
Metal.
Metal. And everything that was not a conductor was non-metal. Okay. So these are some more words I want you to write. Conductor. That allows electricity to pass through. Non-conductor. Doesn't allow electricity to pass through. Okay, so now that you understand that a conductor will let the electricity pass from one coil to the other, let's try these two liquids. I have liquid A and B here. All right, raise your hand if you see the lamp light. I'm going to put it in B first.
Yeah. Yes.
Is liquid B a conductor?
Yes.
All right, I'm going to put it in A. Raise your hand if you see the lamp light. Is liquid A a conductor?
No.
No. Okay, now, we don't have any data yet, but we have some observations that we can base a tentative conclusion on. This is only tentative, temporary, don't copy it yet. Because B is a conductor, but A isn't. Now that's based on our observations. That's valid and reliable. Valid comes from the Latin word for true, because it's supported by our observations and it's not refuted by our observations. Who remembers what it means when you refute a conclusion? What does it mean, Jessica?
False.
You prove it false. That's not proved false by our observations, but it's supported. So we call it valid and reliable. But it's not good yet, because a good conclusion would tell you how to set it up. And you don't know enough yet to set it up. So we have to proceed further. Now, who knows a question that should be asked about liquid A? One question about liquid A, Jeremy.
Is liquid A only water?
Well, let's find if it has any water. Does A contain, start simple. Does A contain any water? Yes. All right, raise your hand if you know the control question for one. Control, Jackie.
Does B contain any water?
Does B contain any water? Yes. Well, water is a controlled variable. Why is water a controlled variable? What makes water a controlled variable, Jake?
Because it's in both.
It's in both of them. What's the kind of variable we're looking for? We want to identify?
Differences.
Who knows that term? Harley?
Difference?
No, it is different, but what's the term that we use to describe it? Anybody remember it? Comes from the Spanish word for hand. Spanish word for hand is mano, M-A-N-O. What's the variable called that we're looking for? Nobody remembers that? Darby? Manipulated variable. We're looking for the manipulated variable, right? Okay, now, does A contain, don't say it, I want to call on somebody for this, blank, 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 blank water. Raise your hand if you know what word goes in the blanks. Jonathan? Only water. We could ask about a dozen different substances, but if we find out it's only water, then there's no reason to ask about a dozen different substances, so we save a lot of time that way. Yes, A contains only water. All right, raise your hand if you know the control question for 3. Control question, Austin?
Justin.
Oh, Justin, pardon me. What? Does B contain only water? No. We found a difference, so I can add to the conclusion like a good scientist does when he gets more data. A is only water, but B isn't only water. That's not very specific, but it's better because we have more data supporting it. I might point out to you something you already know. A is the control group and B is the experimental group. Who remembers what's always true of the control group in any experiment? What's always true of the control group? Well, let me ask you this. Which one is treated normally, the control group or the experimental group? Does anybody know? Which one? Control group is treated normally, and the experimental group is different in one way, which is the manipulated variable. Okay, a lot of you ought to know the answer to this question. Why do you only want one manipulated variable in every experiment? What's the reason for that, Jeremy?
Because then you don't know what's causing the problem.
The reason to experiment is to find out what the effect of the manipulated variable is. If you have more than one manipulated variable, you don't know what's causing the result. Okay, well, B isn't only water, so here's the next question we have to ask. Does B contain any blank? Yes. Okay, here are some clues about something I put in B that I did put in A. Don't raise your hand until you have enough clues to narrow it down to one substance. It's a solid, it's granular. Well, Jessica, there are dozens of granular solids. It's a solid, it's granular, it's found in the kitchen, it's white, and it's not sweet. What does it have to be, Shayla?
Salt.
Do you contain any salt? Yes. All right, who knows what the next question about B should be? What should it be, Stevie? Next question about B. Anybody know what the next question about B should be, Jake?
Does B contain only salt and water?
Good. Only salt and water. Yes. All right, now I can change the conclusion because I have more data. But B is only salt and water. Raise your hand if you can tell me in one word what the manipulated variable is in this experiment. What is it? Emily? Salt is the manipulated variable. Raise your hand if you think the salt has anything to do with the lamp lighting. What is it about the experiment that tells you the salt must have something to do with the lamp lighting? What is it about the experiment, Darby?
Does water and salt have
Yes.
B made the light bulb.
Okay. No salt it didn't light, salt it lit. Logic tells you that the salt has something to do with the light bulb lighting. All right. Now, does anybody in here have any idea why the salt makes the light bulb light or the lamp light? Anybody have any idea? I hardly ever find a fifth grader that knows that. So I'm gonna tell you. Salt, well, somebody in here ought to know the name for salt. What's the name for salt? Well, it's not just sodium, it's sodium chloride. Sodium chloride, that's the technical name for salt. And you abbreviate it, big N, small a, big C, small l. This all goes on the back of your record sheet with that information. This goes on there too. Now, if you put salt into water, it breaks up into positive sodium particles and negative chlorine particles. These are called ions. It's the same name as one of the models of the Saturn automobile. Ions, that's a word to remember. You're going to study a lot about ions when you take high school chemistry. So Na stands for sodium, Cl stands for chlorine. You'll learn that and all of the other elements, the abbreviations, when you take high school chemistry. Sodium is a poisonous metal, and chlorine is a poisonous gas. But when they're combined chemically, their properties change, and they're no longer poisonous. They're this good tasting stuff we put on our food. Okay, so when you put it in water, it breaks up into these particles called ions. All right, now I'm going to draw the jar over here. This is the jar. And it has water in it. Plain water. Right now it looks like a plain water. One thing to keep in mind though is that because this coil is connected to the positive terminal, this coil is positive, and because this coil is connected to the negative terminal, this coil is negative. Okay, when you put the salt in the water, it forms all these positive sodium ions and negative chlorine ions, like this. There are millions of them in B. There's a law of electricity and magnetism that some of you may have heard before. It says that opposites attract. Pluses attract minuses. Minuses attract pluses. Positive attract negatives. Negatives attract positive. Opposites attract. If this is set up properly, there's energy in the battery and everything is connected, these positive ions migrate to the negative coil, and the negative ions migrate to the positive coil. They're attracted to the opposite, and they act like little ferry boats carrying electricity. If you tell your chemistry teacher that I call them ferry boats, he'll probably laugh because he'll give you a much more technical definition of this. But that's all you need to know for now as fifth graders. They act like little ferry boats carrying the electricity. So, actually, anything that forms ions, a lot of ions, will act as a conductor and will make the lamp light. Salt is only one. When you get to chemistry in high school, you'll learn a lot of substances that form ions when you put them in water. But there are some substances you can put in water that don't have ions, that don't form ions too. Okay, well, now that you know what's in there and what's causing it, let me try it again. Raise your hand if you see the lamp light. Why isn't the lamp lighting?
It's only
What isn't in A?
Sodium chloride.
And what else isn't in A besides salt?
Salt.
No ions. Good, Harley. Okay. Raise your hand if you see the lamp light. What do we know are in B? Ions. Why do we know there are ions in B? Because it lit up. All right. Well, now that you know that, make sure that,